Okay, so it's 9:20. I've got to set off at 10 o'clock for a funeral, which luckily is at my nearest church, a mile away, and of course where I'll be playing the organ. So that gives us the only time, possibly all week, to look at a CB radio. We have a repair here, which is the early version of the LCL Communicator NI440DX. That's the one with the yellow meter rather than the one with the other colour meter. I actually find this version works better. Now you need to have the square connector, which is the workman type whatever. I've covered that before. We'll use crocodile clips. Customer says no transmit, no power indication on meter. These tend to be very reliable, but they rarely are set up properly because they are difficult to set up. They don't use a conventional FM demodulator, I see. It's done with transistors. The transmit clarity on these is absolutely superb. Don't normally have any difficulty getting 4 watts out of them. And when we did our tests in 1983, these came out one of the top. Yet I read that these are a bleed over box, but it's not what we ever found. So there you go. The panel of testers were in Rotherham and in Nottingham. So 2 busy working towns with a lot of CB use in those days. And I think this scored something like 89% as an overall score. So much so that a friend of mine I was working with asked for one as a wedding present. So there you go. And he could have asked for any CB available. Back in these days you got a half decent speaker as well. What has that been soldered with? I think it was plumber's solder with no flux. I'm sure we can improve on that when we put it back together. I think under the circumstances we'll take the bottom off with it actually having a fault on it. Now these are relay operated for the transmit receive. When I first saw that back in 1981 I thought it was archaic, and yet a lot of the current radios, as I record this in 2021, probably 50% of the current new radios have gone back to relay switching. I just find that unbelievable. So you'll see the board is labelled UK 4000, which tells us it's a Serpent. UK 4000 was actually the main reason for these to be made in the first place. Not sure why that resistor's there. Have I seen that before? It looks factory. I'll have to compare with one of our own sets, and I'm going to parallel do one of our own sets at the same time. It won't be done on camera, but when I come to take the readings, I'll look at ours as well, and then we'll see whether ours performs better or worse than this customer's one. So they're manufactured by Miki Industry Limited, made in Japan. Radio care, service and repairs, radio, TV, audio, CB, etc. 18A, Out Westgate, Bury St Edmunds. We'll better look that up on Google Street View. See whether it's now a takeaway. So these use a Sanyo LC7137. And that is not the right lead. We were doing that realistic walkie-talkie last, so we'll take that off. We'll use the crocodile clip leads. The upper one and the lower one. and we'll pop the voltage up to 13.8 because it was on 12.8. Connect it to the test equipment. I'm expecting a delivery of building materials. They've got as far as doing the floor, so I hope they ring the bell, which will then go through the tannoy system here and not just sit there expecting to be noticed. So we'll connect up the... I don't think we need a microphone for it to receive on these. So if I put the signal generator on 27791T5, which is UK channel 20, because with him saying there's no transmit or red light coming on, it just tells me in between the lines that it actually receives. It does, but not well. Oh, I'll take those words back. Doesn't work, not as bad as we first thought. So let's have a look at receive. We'll start with that because that's working. So we'll do customers, which is, there is a serial number, 0162209. So the receive, we'll switch picture in picture on. Be even better if the crocodile clip stayed in place. That's not showing where I want it to. That's where I want it to. So we'll look at the synod meter. So, we'll do 10 dB, 12 dB and 20 dB because I don't know what it says in the book at the moment. So, just see if we can change scales. No, we can't. So for 12 dB, it's doing 1.45 microvolts, which isn't brilliant. For 10 dB, it's doing 1.3 microvolts, and I don't even know if it will do 20. Oh, it does. Some radios don't. Actually, it's not bad. It's 1.70 microvolts. So it's all around there. Now I'll need to dig a mic up from somewhere. It's if I remember rightly, it's same as a Cybernet, so that might fit. So to make sure we've actually got a microphone that's wired right, let's go over to public address. Testing 1 2 3 4 5 5 4 3 2 1. I wonder if Roger Bleak works in PA. No. So we know that we've got the right mic. What we haven't got is the radio working. Now I can hear the relay clicking. Let's put that up to the microphones. So it makes the... I've just heard a big vehicle draw up, so I'll just go and pause the video. Oh, it's late in the evening and we'll put a bit more time into this. So looking at the circuit diagram, you should have 8 volts on receive, which we clearly have because it's receiving and the receive light is on. When we're going to transmit, the relay switches that 8 volts to transmit, and the TX light comes on. Now these are bulbs, so of course the bulb could have failed. So let's get the test meter. Before I start messing with the VCO, just check if it's a yeah, that's fine, so we can do some checks. Well, we may as well just turn it over and prod around the relay. Oops, and turn the volume down. So we'll pop the earth onto chassis. Try and remember where the relay is. Put that soldering iron on. That's not right. There's a solder splodge. Okay, so if I prod around, we'll find 8 volts, no doubt. Ah, there we are. So press transmit. Oh, and it now transmits. Okay, so switch off. Let's try that. Good. So switch picture and picture on. Just make sure we select the right camera. That's better. Mind you, high and low power are about the same. Two and a half watts on low power and 3.1 watts on high power. Make a note of that. TX equals, I can write on my hand, just look at deviation. Wow, how stupid is that? I don't know how many channels they're wanting to transmit at once on this, but see where we are. 107. That certainly is just. Well, I'm going to check the VCO, seeing as. So we need to select channel 40, monitor pin 17 of the synthesizer chip. So it's a 20 pin device, so that should be 17. That should be 17. See, we are on channel 1. You know, it's all a bit low, but it's not being altered. Let's see what happens if I alter the transmit one. Make sure I do it on channel 40, it does help. It's supposed to be 4 volts on channel 40. It's supposed to be 4 volts on receive. I don't know why this is, but I'll put it there somewhere near. Just check transmit again. That's now out. So I've got them both at 3.5. Let's see where they are on channel 40. 2 point something and 2 point something. That seems safer to me. Hate it to not work in particular temperatures like a modern set. I'm thinking of those blue display Midland 78 plus multis we've got in the cars, until we replace them with Harvard 420Ms as soon as I can get hold of a few. Right. I'm going to have to look at my notes to see where we proceed from here. Right, let's go on to setting the frequency. So I'll put that on the frequency counter. We should have 2779125. So it's not quite out of spec. It's 2779086. It certainly wants adjusting, but it isn't out of spec. Do drop with age. So we'll just the yellow Crimmel trimmer. There we go. Well, that's a good start. So I'll just have a look at my notes and then we will run through the receiver. It is a bit unusual, I know. Mind you, I've got memory like a sieve, haven't I? Right, so I've worked out some of this. see if we can get anything on transmit. You can see we've got a broken core. So we start with L7. Now the one there is 10.24 output. Theoretically, capacitor 49 is where we would test for maximum. Can I find capacitor 49 there? 48. Yeah, capacitor 49's there. I'll just see whether we can. I want the other meter for that, or the oscilloscope. What's handy? We'll come back to that, because neither of those instruments seem to be kicking around. So we'll start, as we say, with transmit. And that's broken. So, we're going to have to unpower the radio, unsolder the coil, and see if we can turn it around the other way. So it's no longer just a tune-up, is it? You don't believe it. We're now on what, 13th of December, and a church where we tune the organ from time to time, like every 3 years, has contacted me. Can we tune the organ for the 20th? Well, you know, we did all those end of October. So I said, well, my assistant isn't going to want to come down from Bradford for one job. So is there somebody who's going to be able to hold the notes and that for me? Yes, there will. So looks like that's one of quite a number of tasks to do on Tuesday. You know, it takes about 2.5 hours. You know, these printed circuits aren't the best. So this church's carol service is on the 20th of December, and then, you know, they ring me yesterday, can we tune the organ? Unbelievable. So I'm able to hopefully get this out. And we can turn that round and put the dodgy bit in. I managed to get it in the threads. So I'll just start screwing it in a bit. We'll get that popped back in. Right. Power back on. best off with the yellow RS tool for this. That's a soldering iron stand on the next shelf down. Oh, this might be not one that does 4 watts. I think about 3.2. Make sure that's not in some silly position. Well, it might improve when it cools down a bit. I mean, I've been in transmit for 5 minutes doing that. So we'll go through a few of the other things. I'll do low power. I'll switch it to low power, and it's doing 2.5 watts. So low power is there. It's a little bit dirty, that one. Got 400 milliwatts now on low power. Transmit meter. At the moment I can hear it banging across. Oh, of course, I forgot I'm on a crocodile clip, aren't I? So I'll be careful how I upend it. So we'll set it to 4, whatever it's actually doing. So that's that done. Now that's going to leave deviation, which was ridiculous. So deviation's VR1 just there. Need to bring it down from 7, don't we? Wallow. I'll do. And the Roger bleep. Just listen to that on our monitor receiver. Oh, I'm on channel 9. Have I not? I put channel 9 on instead of Roger bleep. Yep, that works. Right, well that's a transmitter. I don't think we're going to get any more out of it, but I'll come back to what it's actually doing when it's cooled down, and we'll see at what voltage it actually does do 4 watts. Just see quickly. It'll cool down a little tiny bit. Let's see what it's doing. About 3.2. So that brings us to the receiver. That wasn't fantastic, but I've seen worse. So we'll start by, like we usually do, putting the oscilloscope on. Turn the bench light off. And adjusting the detector coil, which is 17. So I want an S9 signal, which is 100 microvolts. I'll just make sure that that's maximum recovered audio. And the answer was it wasn't. So now we want about 4 dB on the synad meter. And we'll start with L11. Gained a bit there, so we'll drop the attenuator. We're always trying to keep it as low a signal as is usable. That's no improvement. That was an improvement. No improvement. No improvement. Don't really want to adjust that. We'll just see what happens if we do change it with synad. Oh, we can do that with synads, that's alright. I was going to get the oscilloscope on that on capacitor 49, but I think we've got the result we were looking for. So let's see, we've got sensitivity now under, say, 1 microvolt, because it was 1.45 for 12 decibel synad. So let's see what we can get. It's 1.2, so I'd like to get it. I'll give it another go through, just see whether we can get that little bit more. No, I think we are where we are. Just check that detector once again. I will also, something I didn't check, I will check that we've got the RF gain at full. Yeah, we've got RF gain at full. I mean, I did check, but they can get clonked. So let's get another reading. So for 12 dB, yeah, 1.2. So at 10 dB, it's now 1.1. For 20 dB, it's actually strangely very good, but it's still 1.7. So we've got a bit more out of it. So what will it actually hear down to? Let's turn down the things. About 0.3 microvolts. So it's not the most sensitive set in the world, but it is now set correctly. So I think we will turn it off overnight. Oh, well, I'll tell you what, we'll set the meter to receive. So at the moment it's gone beyond plus 40. So our S meter is the preset here. Yep. And then we just need to check Squelch. So turn the Squelch to full. It's not ever coming in, is it? So no. Take that picture off. So I've got S9 100 microvolts on the signal generator. So the Squelch preset is the one there. There. Doesn't look like it ever wants to come in then at S9. Well, when does it want to come in? Let's put it up 2 stages. Oh, let's put it up a lot. Well, I can't ever get it to open at the maximum signal I can give the radio. No, it's just coming in there. So let's see what that is. So we'll go to the other end, we'll go to the sensitive end, switch the signal generator back to standby at 0.3 microvolts. Set the Squelch. And switch the signal generator back on. You know what, I've cocked that up, let's try again. And switch the signal generator back on. So it boots up at 0.3 microvolts. So we'll advance the signal generator 1 microvolt, 3 microvolts, 10 microvolts, 30 microvolts, 100 microvolts. Oh dear, that's a rubbish Squelch. I wonder if the control's dirty. Let's look once again at this. Right, so we'll do all that again. It's what? It's awful. It's about 13 microvolts for the sensitivity, for the minimum sensitivity. Just have another look at where we are with S9. Put it on full. See where we come in. I think we're going to have to change that preset, but I don't know how we're going to do that because we haven't got any vertical ones. We'll come back to that tomorrow if there's any time tomorrow. Well, that to me is strange. I've just taken out the preset there and it's a rheostat. It has two legs. It's not a potentiometer. And it's 50k. So we don't stock vertical presets. What I'm thinking of doing is try and fit to 47k potentiometer in. We'll snip one leg off. Obviously this is far higher quality. So I'm going to leave it with one side and the wiper, of course, so it's going to act as a rheostat. So we'll see whether we can get that to go in the available space. Tell you what we'll try and do first. See whether we can actually make it go into this side. So we get the spacing right. It's not far out actually. No, it's not far out at all. It's going to be fun putting this in. Try the surgical scissors instead. Right. I don't know whether we've got to try and apply some switch cleaner to the other squelch control, the main squelch control. But we'll see how it acts now. Right. So that's the most sensitive position, so we'll try it in that position. So I'll put the squelch to full. Ah, that's more like it. It won't go beyond 1 microvolt. So let's see whether we can squelch out 30 microvolts. So I've got the squelch control on the front at full. Yeah. So I've now set the signal generator to 100 microvolts. See if we can get it in. We can. That's 30 microvolts. That's 100 microvolts. That's exactly where I want it to be. Right, now we'll go down to the opposite end. So we'll turn the squelch down to minimum. Turn the signal generator off. Set the squelch to threshold. Switch the signal generator back on. And let's see where it comes in now. It's creeping in at 3 microvolts. So that's a bit more acceptable. Good. So I'll just we'll just put picture-in-picture back on, and we'll just look at the meter on the test set, and just see what the power is from cold. 3 watts. So that hasn't come up. So let's have an experiment. I know it's not my set. We're not going to go beyond 14.4 volts. Let's see at 14.4 volts what the radio will produce RF wise. 3.5 watts. Let's see what we can get on the Zetagi meter. I'm going to need a patch lead for this, aren't I? Oh good, it's doing 4.5, 5 watts on the Zetagi meter. And that's at 13.8 volts. Good, right, well, we'll put the lids on, pop it on the aerial, and Bob's your uncle. So we'll just have a flick round this. There's a bit of something there. One niner Roger. We didn't get anything there, did we? But that's nothing usual. I don't think they're out of bed yet. It's so early in the morning. So we'll do a test later on with Mr. Chippy, and we'll see how that performs. It's not quite as sensitive as some sets, and it's not quite as good on transmitters as some sets. But we can get the, what was it, 3.5 watts. We got a kind of charging voltage. That's well on a par with with what current radios do. But I will test ours before we do the scratchy corner test. I will just show what my one does. Perhaps mine works better, perhaps mine works worse. We'll find that out. But it seems a good opportunity while I've got it in mind to take that one of mine off the shelf and just go through it, and then it's done, isn't it? So thank you for watching the LCL Communicator NI440DX from 1981.